material into smaller pieces. There are many different types of grinding mills and many types of materials processed in them. Historically, mills were powered by hand-working animal, wind or water. Today they are also powered by electricity. The grinding of solid matters occurs under exposure of mechanical forces that trench the structure by overcoming of the interior bonding forces. After the grinding, the state of the solid is changed. The grain size, disposition and the grain shape. Milling also refers to the process of breaking down, separating, sizing, or classifying aggregate material. For instance, rock crushing or grinding to produce uniform aggregate size for construction purposes, or separation of rock, soil or aggregate material for the purposes of structural fill and reclamation activities. Aggregate milling processes are also used to remove or separate contamination or moisture from aggregate or soil and to produce dry fills prior to transport or structural filling. Grinding may serve the following purposes in engineering: increase of the surface area of a solid, manufacturing of a solid with a desired grain size, pulping of resources. Grinding laws. In spite of a great number of studies in the field of fracture schemes, there is no formula known which connects the technical grinding work with grinding results. To calculate the needed grinding work against the grain size changing, 3 half-empirical models are used. These can be related to the Hucke relationship between particle size and the energy required to break the particles. In stirred mills, the Hucke relationship does not apply, and instead, experimentation has to be performed to determine any relationship. Kick for D more than 50 mm, bond for 50 mm more than D more than 0.05 mm, Wandrichtinger for D less than 0.05 mm. With W as grinding work in kJ/kg, C as grinding coefficient, Da as grain size of the source material and D as grain size of the ground material. A reliable value for the grain size is Da and D is D80. This value signifies that 80% of the solid matter has a smaller grain size. The Bond's grinding coefficient for different materials can be found in various literature. To calculate the Kick's and Rittinger's coefficients, following formulas can be used. With the limits of Bond's range, upper dB equals 50 mm and lower dBl equals 0.05 mm. To evaluate the grinding results, the grain size disposition of the source material and of the ground material is needed. Grinding degree is the ratio of the sizes from the grain disposition.